This is getting serious. While building a flip dot display, I need to experiment a lot. And one of these experiments is how many volts and amperes do I need. So I had to buy a bench power supply, this thing. And then, after buying all the needed electronics, I have created, as always, a very professional assembly. Yeah, this looks horrible even by my standards. But you know what? For a prototype, as long as it works, I think I'm good with this. Now let's see how it works. I can move one dot at a time. And I can move all of them at once. One very important thing, I don't know if you can see it, but in parallel I can only move 3 dots at a time. So this, and this dot are moving in parallel, and this one, the top right one, is a bit slower. It is a technical limitation. The more dots in parallel I want to move, the larger power supply I need. In the final build, I want to see a laptop power supply, and it allows me to rotate 3 dots at the same time maximum. For my non-technical viewers, I would like to stop here. If you are not interested in the technical details, please hit the like button, consider subscribing, and keep in touch. And for my technical people, there are a few things I would like to share with you. So right now we have a 2x2 flip dot display, and each dot has a direct driver. This approach works fine, but for the final result we would need a ton of drivers, which is not good. So this is great for prototyping, but for the final result we're not going to use this. Instead, we need to create a matrix logic. So again, for an example of a 2x2 flip dot display, we would have shared rows and shared columns. So let's say if we want to fire this dot, we would fire column 1 and row 1. For this one, coil 0 and row 0, and so on. This approach saves us a lot of drivers, money, and this is just better in general. But there is a problem with this approach. Let's say for this example, if I want to fire this dot and this dot at the same time, means that we need to fire this column, this row for this dot, and this column and this row for this dot. You might already see it, but with this approach, this dot and this dot are fired as well, which is incorrect. It is called ghosting. This is our problem, and I'm not sure how to solve it at this point, but we'll get to it in the future. So yeah, something like that. I haven't even started talking about these guys, and that I need a lot of them, but I'm sure we will discuss it later in the future. For now, I think this is it. There are many challenges I need to overcome. I probably need to create a custom driver, because the current one does not work for the matrix logic and it is too large. I need to design and order the final PCB. I need to create many more electromagnetic rods. I need to paint one side of the dots in yellow, and I'm sure that in the future there will be more things to do. This project is quite challenging, but I'm sure we will overcome it. Everything will be fine, and I'm very excited to see the final results. Thank you. Keep in touch.